Okay, let's roll it. So today we're going to try to find solution for Advent of God 2024, last year, the 18 RAM run. Okay, so you and the historians look a lot more pixelated than you remember. You're inside a computer at the end of school, and just as you're about to check out your surroundings, a program runs up to you. This region of memory is not safe. The user misunderstood what a push-down automation is, and their algorithm is pushing whole bytes down on top of us. Run! The algorithm is fast going. Okay, so space every nanoseconds. Okay, you're fast. You create list of which bytes will fall. Your puzzle input in the order they land in your memory space. Okay, your memory space is two-dimensional grid coordinates from 0 to 70. So it's a square, right? So we have a square, and for that purpose, this is limited to 0 to 6, and this one, and the following list of incoming bytes position, this one. Okay. Each byte position is a given coordinates, so this is x, this is y, it's distance from left. Okay, and your historians are currently in the top left corner in the memory space, so that's fine. And the bottom will be 66. Cool, so we are 76. So probably will be 70, that's maximum. Okay. And this is example. You'll need to simulate the following bytes and to plan out where it will be safe to run. For now, simulate just the first few bytes. Okay, so we don't need to do all of this. We need just, for example, pick some portion of this input data. Gotcha. As bytes fall into your memory space, they make that contain corrupted memory, blah blah blah. Okay, you also can't leave the boundaries. Okay, so we have this is an example. 6, 7, right? So if you start 0 0, this will be 0 6. This will be 1 2 3 4 5 6, and this will be 6 6. Okay, and we will only need to check 12 bytes. So we probably from the top we need to only have 12 coordinates. That means our bytes, and those are here. So we will have 5 4. This is 1 2 3 4. This is 4 2. This will be 4 2. 4 5, etc. Okay, so probably we need this list. Okay. Looks fine. So okay, and we need to find the shortest path. Yeah, so looks like shortest path, it means A-star algorithm. So we try to do goals to close to this to this point as much as possible, and we will try. So you can steps up down, so you couldn't go diagonal, only left right. So we can already calculate the shortest path available, right? So how many points bottom, how many points to the right. So it would be ideal situation. And simulate, and this is our main task, simulate one cell. Okay, I'm going to work on using Crystal, and I have already prepared a lot of my files. I have built my library, how to run all this days tasks. So this is my template for all new days, and then we will have day 18 spec. Okay, cool. So this is my test. Let's split the task. This is actually the most common problem in Advent of Code. So if I would remember previous year when I used star A algorithm or shortest path algorithm, I would probably go and just copy paste. Right now I'm going to do from scratch. So what we need to do first, we need parse input, then build a field. There's few ways how we can do this. Just use a simple hash map. It would gives us we need to store only those points, and it should be enough. All right. Only the problem how we want to store outside of, like, to check borders. Or we can use array and build matrix, but if I get this one, so we will have 70 multiply 70 bytes. In our case it will be 8 bytes. Wait, 4 bytes. This will be memory. So there's multiple solutions. I usually go with hash map. It's much easier to just fill the gaps and only check if there is if I have something in blocked or not blocked. Right? Okay, so we'll need to decide which field we'll decide, then find shortest path and calculate the distance. So this is good, like we don't need actually to return the full path, so we just need to find a number, how many of what we pick. So let's first do because I'm not hurry, I'm not doing for time, so we just start with test. And let's learn a bit of NeoVim. So this is our test. I need less time. Okay, so 8, and then it will be 24 lines. So we have it requested 12 bytes only. So I would assume that part 2 we just change the scale. So instead of 1 kilobyte it will go to all data. So in our case it will be I have it here, so it will have 3 kilobytes of data. So probably the second one, just how fast we can solve it. Okay, so this is our input, and then we want to check the answer. It should be 22. Right. What's next? So what can we do? This is different spec, day, and a run test. Yeah, it should not work. Yes, as expected. We have is not implemented, and we raise 0. Nice. So let's make our field. So it should be coordinates, and coordinate is something that I have a tuple of integers with x, y. It helped me also to print the map for debugging. And then this one, actually we can do char just for visualization. Okay, so that's fine, we don't need skip, and there is a nice function to test that it works. We can just print values. So this is, we read information 5.4, and the last one 2.0. Right. So instruction is a string split by comma, so we split it something like x, y, instruction split, comma, and map character to integer. Probably 32 is enough. And then we add this field, this key, and we put this similar symbol as here. Right. So then we can do field, and it has some problem. Mutable. Let me remember how. Yeah. I need to make sure it works. Okay, so it's not just tuple, we need to do this one. And I would like to show yours. Okay, no big problem, but because over here it was string and then we want to convert integer, so it doesn't work very well. Okay, cool. So this is our field, and to make it more visible, what I would like to use is I want to print it, but I don't want to print it when I run application. I want to print when I enable for debugging only purpose. And I have a function called sprintlen. Should be like this, yes. So, okay, so this is we call map, so I will be consistent with my other solutions. Then height and width. Yes, so actually let's keep height 6 and width also 6. So we don't need to print everything, we need just print 12 of this one. And let's run it. Cool. So we don't see anything because I should see this when I enable specific flag when I build my application. So it should be done with -d define. Okay, so yeah, so this is not from this world. And we have it, right? Something like this. Right, so here we need to stop on 12. So I would say, let's say, only read 12 things. So how can we do this stuff? So there's few, it's like just 0, 12, it should be enough. Right, so we have this one, and this is the screen. The width should be 1+, right? And the height 1+. Right. So now we see a map, and it looks like similar what we have here, right? And this is, you see, specific lines. This is lines, and probably if I scale to bigger picture, right? So it was here. Then we will see that I need to go like this. Okay. So here we need to return the distance. I would say let's put the result, and we will return the result. And our algorithm goes here. So we need actually shortest. Okay, so we just return shortest, and then we have up, and we need to start point and end point. As a start point should be something like chord 0 0 and endpoint should be something like x6 y6, right? Okay, so the simplest way we go from this point, like if there is no blockers, we go from this point to this point, and it should be x plus y. So it's like endpoint x plus endpoint y. So run test. So it doesn't work like this. You should probably do like this one and this one, right? Right. So cool. We have to. It doesn't work well, right? So we need to actually go find the closest way. So in this case, it's kind of similar to bread. We need something like star A algorithm, that's combination of BFS and DFS. So when we using short pass algorithm, one of the way, if we go to deep search, we go to one direction, we blocked, then we go to one direction, another direction, and try to find neighbors, and instead of check all neighbors in same time, that's when we go from here to this point, we will go through all dots. It will not effective because we don't need actually to check those points, maybe, or we don't need to check these points. So what can we do? Let's go and build the primitive one. We take, so because we know the start point, we will ask all neighbors, and then we try to visit. Either we go to the first neighbor and try to check all his neighbors, or we just build closest neighbors and try to identify next step from our neighbors. So first one, we want to create some sort of queue, and the queue will be our start point, right? Then while queue empty, actually not empty, right? We want to check all neighbors, right? So we pick this one, we pick this point, so we try to pick the first one in the queue. So we take this guy, shift, so first one for the queue, and try to find all his neighbors, right? Right, so like I just try to think about how, like, start from simple one, or try to even use try to sort neighbors by prioritization, by distance between this point and this point. Okay, so let's try to do, yeah, this. Let me first create breadth first search. So what we want to do in the first step, we want to try find all neighbors. We start with this point, try all neighbors from this point, and then we build a new queue 1 2 3, try to all neighbors from those three, but at the same time to not visit the previous one because it will be closest one, and then we will find all neighbors from this one, then all neighbors from this one, until we don't reach the point of this, right? So probably we'll have kinda 6 iteration, 1 2 3 4 5, yeah, 6. So what does it mean? We will want to have a new queue that will be, let's put set. That means here I also need set, right? So, and we go through all queue each do card, and we want to make sure we should add to visited, so we want to keep all points that we already visited. Let's create another set, so because it should be like card new, it will be empty by default. And what we're doing, we check, okay, we first mark that it's visited. Right, so we want to check all neighbors of it, but we remember, okay, we mark this visited, so don't add anymore. Now we want to have all neighbors from this coordinate. Because we have up, down, left, right, so for example we have this point, so we need one, each point has 4 neighbors, possible guys, and this should be, and I think I do like this, so x let me try, maybe I already have it. Neighbors, yeah, so I already built a function to find all neighbors. Okay, so I built an array of coordinates, then I took the array point where is this located and try to, no, this is too much, it's too many, but anyway, this is the idea. I go through points. So in my case I need only 4. Okay, so I need only 4, so I would say I need chord new, and then I have the current point chord for example we will take -1 from left, and we still keep the same y, right? Then I'm going to do mostly the same, except I I'm going to different direction +1, and then I need to do something like this, and then it should be like this, except this should be okay. Good. Yeah, so we find 4 neighbors, but we don't know like is it valid or not valid point. So how we want to validate, we go through each neighbor, and I don't need this variable anymore, so we want to have go through all neighbors, and then I want to validate. Okay, if the purpose why I built map is to check the boundaries. How I will check that my map is this point presents in hash map or not. But because I only add those dot points, that means I kinda don't need actually a map. I can do like, okay, so first of all we will check includes, I think it's include neighbor, so we will, it should not include, so if we'll check that it was not previously included, right. The second part, we need to check that neighbor x bigger equal to 0. Similar we want to have for y. This is a simple one. And then we want to check that neighbor x less than, okay, so here we need to give borders, right? With height 6, width 6. Let's change to 7. So we want to have height this one and neighbor y width, right? Okay. Okay, let's format it. And what we want to check that it is not included. Okay, and map has key neighbor. That means there is a border, so we don't need, so it should not be included in previous one. It shouldn't be included in our borders stuff. Okay, and that means we want to have next. We want to add this potential neighbor to the queue. probably it will be added already by some else, so I need to check that. If it's already existing in the new queue, it's fine until it's not added. Okay, something doesn't work well. Let's run for just check. What don't you like? Unexpected. If I do like this, and Shift A. Yes. It seems like Crystal doesn't support this. Okay, let's continue. One, two, three, four. Let's continue. Okay, so what do we have here? Okay. Where's finished? Yeah, so we did pick next neighbors, go through all neighbors and identify which of them we want to add to the new queue. So it should not be visited before, it should not be a blocker, and it should be in the border, right? So what to expect? The first one, they start, then it goes this 3 point, then it should go this 3 point, and then it should go 3 points. So eventually, when we reached some time, we will be kinda here, then we go to this, then this one, like, yeah, it should work. So after we go through all queues here, now we want to replace old queue with new one, and if there is no neighbors anymore, then it should be go out. Also, what can we do actually? What I did wrong here. So why this wouldn't work well? No, actually it should work fine. So what we need to count is the distance. So for example, it will be 0, 1, then we have this 2, then we will have 3, 4, yeah, so the result of this, when we reach the last one, so when we, for example, if, actually we can do like this one, if neighbor equal our endpoint, then we should return distance, or I. And in our case, I will start from 0, and every time we increase I like this, right? So it should be, I think it should be the shortest path, right? So we will come from this tower point, then we pick this neighbor, then this one neighbor, then this one, yeah, so it should be fine. Let's test. Okay, so there is initiating set new, and where it was 39, here, so it should be court. And that's what's yellow here. Um, not include, it should be includes. Yes, okay. Many different languages, like even in Crystal, sometimes it just includes, sometimes. Okay, so we have 21, so let's assume we start with 1, just guessing, because this we count this one as well, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, so probably 22. Okay. Right. So this one is for start. So we pick this one. Actually we written here. Yeah. Okay, so now rake run. So now I want to test my against my solution. So it should be actually here. So for original one, right? So this will be my 7 with 7, 8, 7. So I would extract this one to 17 one, and width also 71. And for test purpose, here we override height 7 with 7, and services we don't need it, and then we propagate height, it should be height, width, it should be width. So by default we should have 71. Okay, so here the size we should have length. Oh, let's use size. It should be 1 kilobyte, and this is size, and this is size we provide here 12. Let's run test again that it works. Yeah, looks like. Okay, let's run. So, okay, yeah. This simple solution, Brett, it's not right. Okay, let's use 59. Okay, 1 minute. Sometimes just this is the answer, but it's not close enough. Okay, let's do it. Otherwise we need to, anyway, this solution will not be effective for for part 2, I'm pretty sure. So let me run here. I want to see debug. Something like this, and Abyssal. Okay, so because it doesn't say it's too low or too high, we are close enough, so it should try 57. Yeah, so right now there's some typo or miscalculation. For example, this one I check on next one stage. Here. Okay, I got it. I got it. Okay, so endpoint should be chord new, and then we have height -1 and width -1. It should be y, and this should be x. Right. So it actually doesn't matter, right? So right. Okay. So, and you see, this is how it started. Labyrinth. It's something like, I see that it's in close to the corner, so it could happen that maybe next one they will combine this map with extend to the right, also to the left, to the bottom. Okay, let's run test again. Just check that it still works. And now we run again for sometimes visualization helps, and this is a button, so it's visible or some probably single player. Okay, yeah, and it's still running. So this we should optimize, like we should not go here or here. Actually, we should check. Yeah, cool, as expected, right? So let's save our work. It's not optimal, and we will doing advent of code 18 part 1. I just want to save. Okay, so let's part 2. Part 2. Historians are not used to moving around in the pixelated SU. Universe SU. Okay, cool. So he has some abilities. Probably he will twice faster. Okay. You're afraid they're not going to be fast enough to make it to exit before the path is completely blocked. To determine how fast everyone needs to go, you need to determine the first byte that will cut off the path to exit. Oh, interesting. And the above example, after the byte 1 falls, this one, they still pass to the exit, right? However, after adding the very next byte at 6-1, so it was 1-1 here, and then we came to 6-1. There is no level path to exit, so we are totally blocked. Alright, yes. So in this example, the coordinates of the first byte that prevents exit from being reachable are 6-1. Simulate more of the bytes that are about to corrupt your memory space. What the coordinates of the first byte that will prevent the exit from being reachable from your starting position? That's how it could be done, how it's possible to block your way. What I'm thinking about is union. So if we count all connected points of the kind of shape, and if it's counted through all from 0 to 6, yeah, that means there is no block, there is blocked way, and there is also block way like from top to the bottom, right? So if we try to use some sort of union, but for union in this case we need to connect by diagonal as well, right? So this is one solution. If we try to use union, find and could not find the path. The third one, we built the short path. So if we build the short path, for example, there is another way, right? So every time we can build one short path, and then we add a new byte until something is overpass our my path, and then we need to recalculate the path again. For example, we reach this point, we say that this one is not reachable anymore, so we want to recalculate. And if we could not find the path anymore, we are there is another solution, right? So recalculate every time the path. Okay, so we are doing the next. We still keep, we want to have this test. We still use this similar approach, except it should be 2, and then okay, so what's the answer? Coordinate the first byte that prevents exit from reachable 6-1. Simulate more of the bytes that are about to corrupt your memory space. What are the coordinates of the first byte that will prevent to exit from being reachable from provided are 2 integers split by okay, so this is our answer. So what we expect is something like 6-1, right? Should be like this. Oh, we want to do this a string. Like this. Okay. And then we change test to this one. And then we want to run test for line 40. Yeah, there is nothing similar to the problem. We want to duplicate this one. Oh, I didn't remove it. And I don't need this one. And I need this one and whatever we want. Okay, and this is we built our map. Okay, the primitive dump space is like we can guess the size, and on this step we want to build so this is, we know that it's reachable. So what can we do? Like dumbest way, we can kind of iterate and try to find shortest path. If it's not possible to find, that means this one not that exit here, but it should return here. Return nil. Right, so first we prefill the size, right? We prefill it, and then we start to do guessing stuff. The maximum allowed, so we can do like we can say, for example, we have max record size, and then we prefill the size. We prefill the size, and from this step we are going to add one by one. So size, for example. Okay. So what I'm thinking, we can do this. Try to identify if we can find shortest path between size and n. If we couldn't find shortest path, we divide by 2, and then then we check between size and n, etc. Right? So so every time we need to kind of build map. Okay, let's try this one. Okay, let's try let's try to find the shortest path. Yeah, cool. So let's and return shortest path. And then if we could not find, okay, so let's do this. Recursive or not? Okay. So we have high and low. Low is equal size, and high is equal n. Right? So now we want to calculate mid, and mid will be high minus low and divide by 2. Right? Right. So I need to remember. So this is, for example, will be 12, and this will be, how many of them? 24. So it should be 24, and that means this one would be something 6. And then we check what we check. Then we check shortest path. So we put this one. We kind of rebuild map from scratch. So we want to do this map. We reset the map. So initialize map. And then what we need, actually we need to reach for mid, and that we build map. Then we try to find shortest path. So this is we want to finish. That's fine. Let's put it. This is constant. This is shortest path, and then if this is nil, then we override high equal mid minus 1. No, actually we put mid. else we set low as mid end, right? Okay, and now we repeat again the same and the same. So we don't need this one. And then we need to repeat this one until while high bigger or equal low. Something like this. So we tested this. So if high equal low, so okay, I need to debug it. I'm not sure, like, so for example here it could be that high become 6 and low, no, 6 plus low, wait, plus low, so it should be 18, right? Right. So it means we have 18, then the high become 18, and we start to do with low 12 and 18. So mid will be 6 plus 3, 15. So this should be 15, and then it will be finished. This will be 15, then it will be 1, so it will be 13, and that means this is 13, this is 12, it would create 12 again, right? So this should be 0 someday, low. And when it's go to growing, so for example this will be 18, then we will have mid plus 3, 21, and then it comes again, for example here 21 and 24, it will be 22, 23. Okay, so probably in the end I will have some problem, so let's debug it. Low, then we have mid, and then we have high, and let's separate them. Okay, so test. Okay, so mid should be not float. Yes, so this should be integer. Yes, so as I said, yes, so this is what I have. Low, mid, A, okay. Okay, so what do we have here? We have okay, so we have low 20, then mid still 20, and high is 21. And somewhere I should add minimum, so probably this one should be increasing. I wish I remember this one, right? So Right, so while this one is bigger one. Okay, but then it's not clear if we run the same. Okay, let's see what's happened. Okay, so once we identify mid, it means we need to get, we should see that medium is our, should be like this, and records mid should be our answer, right? Let's try. Yes, so if mid nil, not nil, probably mid should start from, for example, low. Should be nil, right? It should be always something. Okay, so in this case, the mid actually was 21. This one, right? Okay, let's try -1. Okay, so when this is, it should be high actually, right? So we store high, the last one that was unsuccessful. So first we try 12, or mid 18. Mid 18, it should be like this. So we try, yes, 21. But before, why low is changed? Right, so this one 20, it was mid 20, and then we change, it was still working. Okay. One. This is didn't work, right? So on 20 it was successful. On 20 it was successful. High didn't change, so this was wait, something goes wrong. So the one, yeah, this should be, how many I have? 24, right? So in total we have 25. This should be -1, right? Because records and -1. I think it should have empty line. So right, so what do we have? Uh, 2 0. Right. So actually to 0, okay, and then we need to have tail input day 18, it should be 70. I want to test how I read input. Does it include empty line on it? So we have 17. 1760C. Yes, cool. So this is correct. That means count. Okay, what I want to test if I put 0 and the size, and then I pick the last one. Should be the same. Should be also 1766. Yes, cool. So, okay. This is our highest possible value. This is size. So, when we block everything, okay, so where's my mistake, right? I kinda so okay, we have this one lines, right? 25. So okay, we have 25 lines, and it's blocked on so first 1 and then it should be 1. So 20 it should be last success, and 21 should be first not success. Okay, so we tested this one bit 20. Okay, I would say this one, right? It should be the last one. So we put this is like this. So 0 plus n. It should be this one. And accept. that means this one should be -1. And that means this one, right? Yes. Okay, so we have this our I tried to hide my debug stuff. And I wish it to be something good. Okay, let's run this again. It works fine. Okay, then we have run here, then we have release, and then we run release. Yeah, so on this stage we are waiting. Let's add first, so it should not be big enough. We should see 3000, like, yeah, it should be fine to debug this information. Okay, yeah, I thought this is like primitive solution. I wonder if my theory about to connect all block stuff in the single union, and then when I add a new union, I check that all elements covers either from by X by Y. Oh, it's some answer. Ooh, holy moly. No, I didn't expect that it should be like so fast. Even like with this brute force solution, this one looks very nice. Okay, that's kinda all. See you later.